Good morning. Actually, today we will talk about MATLAB, but before going to the basics of MATLAB, starting by how to define scalars, how to deal with the scalars, and how to define vectors and matrices, and to deal with them and to manipulate the data saved in these variables, we would like to introduce something related to how can we model real world problem that we can represent them or model them in the computer or any computerized system like a mobile phone or whatsoever. So actually, generally speaking, we have two kinds of mathematical models that they represent a real world problem. For example, if you have some problem like, for example, you wanna represent a general phenomena or natural phenomena, you wanna represent it in the computer or in your paper or a book. Either you use a mathematical model. The mathematical model is that it's an equation with terms that expresses essential features. Essential features, it means what? It means these features can be represented using variables in this equation. For example, let's talk about it. For example, I am talking now and you are listening to me. Between us there is a channel. This channel is a natural phenomena that we can represent using an equation. What are the parameters here? These parameters can be the frequency of my voice, the power of my voice can be considered in this one, and also, for example, how many paths my voice goes through to reach your ear. So in this case, we can represent this system using a mathematical model, and sometimes we call it closed form or exact model. An example of these mathematical models is the Newton's second law, A equal F over m, where A is the acceleration of certain body, and F is the net force, and m is the mass of the object. Actually, sometimes it is not easy to derive a closed form formula or a mathematical model of certain a problem. So the solution is what? To approximate, to find an approximation of this kind of mathematical formulas in numerical models. So when it is hard to find or hard to implement, hard to find a formula for certain problem or hard to implement, for example, I would like to simulate, I try to use certain formula in my mobile phone, but the mobile phone cannot really deal with this very complex formula, so we want to map this formula into a numerical model that can be processed using our mobile phones or computers or whatsoever. So usually we use numerical models, and in engineering, let's be very accurate in this one, numerical models are frequently used, much more than the mathematical models, especially for you as electronics students. You would like to implement the systems on chips or as software, so you would like to use the numerical models. Nowadays, actually, all the hardware is mapped into software in systems we call software-defined radio. So in this case, we would like to transfer at least, or we would like to emphasize on the use of the numerical models in our systems. So let's take an example to clarify the issue and to see how approximate can be the numerical model to the mathematical model. So For this jumper, we would like to measure the velocity, the speed of this jumper. This is the formula to measure that speed as a function of time. So Vt, which is the velocity, m is the mass of the jumper, the weight, Cd is a constant, g is the acceleration due to gravity, and we know that this is almost the value. So the independent variable in this case is what? Is t. Then and these are the parameters governing this equation, and based on this one we draw this figure with when t equals 0, the value of velocity equals 0, and then starting to increase until some point it is going to kind of saturation. This formula, what we call a mathematical model of finding the velocity. But this kind of formulas in this example maybe it's not very complex, but still if we want to implement this tangent in our mobile phones, how we can do that? Can we really implement it very easily this time? No. Actually, either we make a lookup table from which we can calculate this one, or we make approximation of tangent function in our mobile phones. So this one leads us actually to the numerical model and how can we use it. So remember this equation, we can represent it using a numerical model. We don't want to discuss the details how we found that, but we would like to take it as an example. Okay, so this velocity can be given as Vti plus 1, means the future value of the velocity, equal the current velocity plus some value. These are numbers actually, t plus 1 and ti plus 1, ti, Vti, these are constants, the three of them square, this one is given, so this one is the old value, so Vt plus, all these are numbers, so the computer is perfect to process such an equation. So it is just you substitute the values of t, and you have current value of Vti starting at 0, and then Vti, and you continue to find the value. So I find this value, then the future value will depend on this value. Okay, so we have initial condition. Initial condition is Vt, and we put it equal to 0. So the solution is not exact. This one is approximation of this equation. This equation is approximation of this one, but let's see how accurate is our approximation. Look at this equation. Look at this figure. This one is the analytical, the mathematical model, and this one is the numerical. As we see, they are very close to each other in all the range of values. Maybe here we have a small error, which is tolerable error. So what we want to say here is that since we want to deal with the numerical models, we need to understand how to implement numerical solutions for certain problems, and this course is all about this topic, because that's why our course name is numerical analysis. So we want to analyze certain problems numerically.